Okay, good afternoon, my dear students. Again, we are step into the new topic. It was very useful for problem solving in 10th class, as well as maybe it is useful for plus 2 students, I mean intermediate students, those who are going to read optics. That is nothing but in previous classes we discussed about reflection and ray rules, how the rays are going to be incident on a plane surface, what happened to the consequence while it is going to reflect, what happened to the light ray when it was going to refract. Refract we did not discuss. In future we are going to discuss about refraction. Reflection was completed by both the surfaces, both the type of surfaces, that is plane surface as well as curved surface. Okay, why the light is incident on any curved surface, reflection takes place as usual. So depend upon the reflection, depend upon the distance of object from the surface, mirror, the distance of image is going to be formed. What is the principle behind this? What is the relation between these object distance, image distance and focal length of the particular concave surface or convex surface? What we are going to use so-called curved surfaces. Simply we set a simple relation. It is visible to you? Yeah, up to here it is good. So we are going to discuss about mirror formula. Mirror formula will explain the relation between these three terms. What are those? Object distance from the surface, image distance after reflection, what is the focal length which was given for the given mirror. Yeah, let you see, before going to this particular derivation we need to take a concave mirror. Yeah, let me see clearly. I am going to draw up to here, it is visible to you now. So let me go to draw the concave surface. Yeah, this is a concave surface. When it is completely termed as a concave surface, once we need to paint outside. Outside is coated silver paint. That means nothing but a reflecting natured surface inside, opaque nature paint outside. This is shaded area. Shaded area will not reflect it. This is red or blue in color, I think. So we are going to see the mirrors. The back side of the mirrors, which was already broken home. Some pieces are there, means if we are going to observe back side of the mirror, a red color or else blue color we are going to observe. That is called silver paint. Okay. For every case we are going to see mustard should be need to draw a middle point, line. This is called principal axis. For this curvature, before made as this curvature, it has a center for this curvature. Yeah, okay. C is a center for this curvature. Let you take an object on this principal axis. Here is the object O. Diagrammatic part is very important for this derivation. If the diagrammatic part is clear, the derivation is very easy. This is object. If you are going to take a incident ray from the object, first incident, because for formation of image mustard should be two reflected rays need to coincide. That means two incident rays required. First incident ray I was going to be taken like with an angle to the principal axis. That particular angle is called as alpha. Is it clear? Incident ray is taken. The incident ray is made an angle with the principal axis. That should be considered as alpha. I want to extend a ray through center of curvature to the surface. If any ray which is passing through the center of curvature, that should be considered as a normal at the point of incidence. This is called normal for the surface at this point. Okay, this is called normal for this surface, this curvature at this point. Okay, it was no need, so I was going to ask. So reflection, laws of reflection. According to laws of reflection, angle I is equal to angle R. That means here is theta is the incident angle. Here is also the theta is the angle of reflection. Reflection takes place. So first ray was going to be incident and reflected back. It is clear. Let me go for second ray. Second ray from the object along the principal axis, which was incident. Here is a reflecting surface. This is also passes through center of curvature. So at this point, this principal axis also considered as a normal. Again, retrace it back. Normal is always retrace it back. So here is a image. And also the principal axis, which is made an angle with the normal, that is beta, and the ray of reflection made an angle with the principal axis, that is gamma. Okay, alpha, beta, gamma. These three are the angles made by incident ray, normal and reflected ray with principal axis. The point of incidence is taken as A. Okay, this is a diagram. Diagrammatic representation is okay, means let me go to the next derivation part. Come to this particular area, it is visible. Okay, nice. Okay, from the diagram, if we are going to see, angle OAC is equal to angle CAI, that is equal to theta. Angle OAC, angle CAI, both are same angles. Angle I is equal to angle R, theory is going to be applied here. So both are equal. Angle I is equal to angle R. We are going to say both are same, and the angle is considered as theta. So let you see, both are same angles. From triangle OAC, could you please say, check OAC triangle? OAC. From triangle OAC, what could we have to write? Sum of two internal angles is equal to external angle. External angle for OAC is beta. Beta is equal to alpha plus theta. Consider as first equation. Okay, let you see. From OAC, we have written alpha plus theta is equal to beta. External angle, sum of two internal angles is equal to external angle. From this, we have to simplify like this. Theta is equal to. I require theta value. What we have to do? Theta is equal to, take this alpha into this side. Beta minus alpha. Keep aside. Keep inside the box. We have to use in future steps. Triangle OAC usage completed. Triangle OAI. Triangle OAI. From triangle OAI. Here the derivation steps only visible to you. Total data what I am going to speak here, you need to note down as a notes, as a theoretical notes. From triangle OAI, could you please observe OAI? OAI. External angle is gamma. Internal angle, sum of two internal angles. Alpha plus theta means 2 theta. Alpha plus, external angle gamma is equal to alpha plus 2 theta. Can I write like this? This is equation 2. Substitute theta value in equation 2. Substitute theta value in equation 2. Could you please see, gamma is equal to, it is look like mu. Gamma is equal to alpha plus 2 into theta means beta minus alpha. Beta minus alpha. Is it visible to you in the video? Yeah. Beta minus alpha. Up to here it's okay. Let me conclude this derivation here. Beta minus alpha. Could you please expand this? Gamma is equal to alpha plus 2 beta minus 2 alpha. Alpha both are going to be cancelled. Let you see, 2 beta is equal to alpha and alpha both are cancelled. Gamma plus alpha is remains here. Alpha plus gamma is remains here. So alpha plus gamma is going to be remains here. Alpha plus gamma is going to be remains here. Is it clear? From first triangle we have written sum of the two internal angles is equal to external angle. This is the theta value obtained from the equation 1. Later from OAI triangle, external angle is equal to sum of two internal angles and theta value is going to be substituted in this, and finally we get the equation number 3. Equation number 3. Yeah, just I want to turn this for the visibility. Yeah. Later, what we have to do? Now, the equation is in the name of alpha, beta, gamma. What is alpha? What is beta? What is gamma? We can take tan theta from these triangles to easy to identify. But these angles compared to this particular small spherical surface, angles are very little. So tan should be neglected. Directly we can write alpha is equal to, according to the trigonometric ratios, tan alpha is equal to opposite by adjacent. So alpha is here, opposite is, I did not mention the P here, pole point, sorry. At the initial stage we need to mention point P, pole point. Okay, so this surface is also very small, so that's why AP is considered as straight line. Okay, so opposite side AP by adjacent side OP. Similarly, beta is equal to AP, adjacent side tan beta, AP by CP. Beta is here, so center to pole CP, and gamma is equal to, gamma where it is actually at image position, so AP by IP. These are the trigonometric ratios. Please substitute these all values into this equation. AP is common in all terms. You can cancel it before substitution only for simplification. So easy to substitute. Instead of beta we can write 2 by CP is equal to, instead of alpha, 1 by OP plus 1 by gamma IP. By using sign conventions, I will tell you the sign conventions here again. Could you please see any object which is any distance which is going to measure opposite to the incidental direction, that should be taken as negative. In that case, image distance is negative, that means minus V. Radius of curvature is negative, that means minus R. Object distance also negative, minus U. So you can substitute instead of this CP 2 by minus, what is the CP means? Radius of curvature, minus R is equal to 1 by OP means object distance minus U plus 1 by IP means image distance minus V. Okay, it was not visible to you. 1 minute. So 2 by beta CP is equal to 1 by alpha OP plus 1 by IP. Now substitute these values with respect to according to sign convention rules. Substitute the values according to sign convention rules. I am going to adjust the cam. Yeah, okay. According to sign convention rules, we can go into substitute here. So 2 by minus r is equal to 1 by minus u plus 1 by minus v. Yeah, okay. If you are going to cancel this 1 by v, 1 by u plus 1 by v is equal to 2 by r. From our previous relation, 2 by r is equal to 1 by f. A relation between focal length through the radius of curvature. 2 by r is equal to 1 by f. By using that, the equation is going to be changed as 1 by u plus 1 by v is equal to 1 by f instead of 2 by r. So here u is our object distance, v is our image distance, and f is a focal length. Could you please recheck the particular derivation totally? With for this derivation, diagram is a heart. If diagram is not properly drawn, or else any term in the diagram you are going to forget, there is no chance to retrieve complete this derivation. For 10th class students, there is no requirement of full derivation. Only was asking you that formula and substitution according to sign convention rules. How we are going to take a minus, why we are going to take minus, why you are going to take plus. The sign convention rules are very important. If you are going to substitute for a numerical problem in the mirror formula, this minus and plus, do not confuse. Read the question twice. Simply I am going to tell you here orally. So for example, if any value which was not given any sign convention, any sign plus or minus, consider as positive. Okay. Unknown quantities should be taken as positive. The quantities which are opposite to the principal axis, opposite to the incident ray, taken as negative. Along the direction of incident ray, consider as positive. Above the principal axis, consider as positive. Below the principal axis, consider as negative. This is about mirror formula and complete derivation. Okay, thank you. We'll meet in another topic.